Do you want to build a real Spring Boot application? Perhaps you've never built one before and you want a project for your portfolio. Perhaps you're familiar with another language or framework and you want to see how it's done in Spring Boot. I have built countless apps over the decade and a half that I've been coding, so join me as we build a task tracking application using the Java programming language and Spring Boot. This project is focused on building a real Spring Boot application, and over the almost 3 hours, we'll cover quite a lot, including setting up your development environment, analyzing the project brief, designing the application, starting up and connecting to a PostgreSQL database using Docker, creating the application's domain, including database mappings and relationships, creating data transfer objects, or DTOs. We'll create mappers to convert from our entities to our DTOs and back again. We'll create JPA repositories for both our task list and our task entities, before implementing all of the REST API endpoints that our application needs, implementing error handling, and then a brief introduction to database transactions. If you want the React frontend that I'm using so you can see everything working in your browser rather than having to rely on a REST API client, then you can find this, the project source code, and the lesson write-ups on the Devtiro community site. I'll leave a link in the description below which gets you access, and at the time of filming, access is completely free. Right then, with that all covered, let's get started. So let's cover what you need to know in order to follow along. The first thing that you'll need is a practical experience of Java. We'll not be covering how to use Java, this will be assumed. That said, we won't be using any advanced features in Java, such as reflection or multi-threading, we just need the basics. Next, you'll need a practical experience of Maven. We'll not be covering what Maven is or how to use Maven, this is going to be assumed. But again, we're not going to be using any advanced features of Maven, simply using it to build our project. Next, you'll need a practical experience of Docker. Simply having used Docker to start up some containers should be enough. Again, we won't be covering what Docker is or how to use Docker, that will all be assumed. Next is Node. Now we're focused on Spring Boot, but there is a front-end component to this project, which is a React application. So we're going to be using npm, so the Node package manager, in order to install dependencies for that React application. So you don't need to know about Node in any great detail, you simply need to know what Node is, what the Node package manager does, and what it means to install dependencies using the Node package manager. For this, we're going to be heavily focused on building our application. We won't be going into any great detail on the theory side of Spring Boot, so it's assumed that you already have a basic knowledge of this. If you've seen the Devtiro Spring Boot for Beginners course, you'll have enough knowledge in order to follow along. So with that covered then, let's now explore how to set up our development environment. Next, let's cover what we're going to need for our development environment. The first thing that you're going to need is Java. Now we're going to be selecting Java version 21 when we set up our application. So you're going to need Java version 21 or later to follow along. You can check your Java version by opening up a terminal or a command prompt and running the following command, java-version. And you can see here the version of Java that I currently have installed. If you see an earlier version, then I'd recommend heading over to oracle.com to download JDK 21 or later. Or if you prefer to use an open source JDK, then you can download it from Adoptium, which is part of the Eclipse Foundation. Either JDK should work fine for this project. Next, we'll cover Maven. Now we're going to be using Apache Maven to manage and build our project. Although you'll not need Apache Maven installed on your system. An instance of Maven will come bundled with your skeleton Spring Boot project, but more on that later. Next is Docker. In order to run the PostgreSQL database that we'll be using for this project, you'll need Docker installed on your machine. To check if you have Docker installed, open up a terminal or a command prompt and simply type docker-version. You have Docker installed if you see a version number like this printed out, otherwise head over to docker.com to download Docker. Next is Node. In order to run the front-end code I'll provide, you need Node version 20 or later. You can check your Node version by opening up a terminal or a command prompt and typing the following, node-version. If you don't have a version printed out here, or if it's not the required version, then head over to nodejs.org to download a later version of Node. Next is your IDE. I'm going to be using the community version of IntelliJ IDEA as the IDE for this project. You can use any IDE you like, such as Visual Studio Code. but I recommend IntelliJ as it's brilliant for Java development. You can download IntelliJ for free from the JetBrains website. So with everything installed, let's check out the requirements of what we're going to be building. In any real-world software development project, there'll be a set of requirements which describe what the system should do in order for it to be considered a success. Let's review the requirements of the task tracking application that we are to build. The project itself can be found on the Devtiro community site. If you don't yet have access, I'll leave a link in the description where you can get access. If you can't join for whatever reason, no problem, I'll be showing all the requirements right here anyway. Once you're logged into the community site, head down to the project brief section on the left here, and then we'll select the project brief for task tracker. And let's expand this. The project brief itself is broken down into several different sections. The first is a brief summary of the project, that it's an app designed to help users organize their daily tasks, set priorities, and track their progress. Next, we have some definitions. They're captured here to make sure that we're all using the same words to mean the same things. Here we have a definition of a task as a specific action item or to-do that a user wants to complete. It typically includes a title, description, due date, and priority level. This is great as it tells us the sort of members our task class might have, but more on that later. Then we have a definition for a task list, which is a list of tasks. Simple enough. But the description tells us that the task list has a name member, a useful piece of information when we come to implement it. Next, we have a list of user stories. If you're unfamiliar with this pattern, a user story describes what a user wants to do with our system from the point of view of that user. This little nuance is enough to give us some additional context over the system must do X or the system must do Y. More context helps us to make better decisions during development. So each user story follows the format as a I want, so that. So we can see here, we have this user story to group tasks into task lists. As a project manager, I want to be able to create multiple task lists for different projects so that I can keep tasks organized and separate. So we can see from this little story that there's a requirement of a user being able to create multiple task lists. Following each user story, we have a set of acceptance criteria. Acceptance criteria are statements which can either evaluate to true or false. The idea is when all the acceptance criteria evaluate to true, then the user story is considered complete and finished. For this user story, we can see the following acceptance criteria. A user can create task lists which contain tasks. Each task list should have a title and an optional description. Our implementation will need to work in such a way to make both statements true. Now, I'm not going to read each user story and acceptance criteria word for word, but let's go through them at a high level now. So here we have a user story to update task lists. The idea is that you'll want to update the name and the description of a task list that you've already created. Then we have a user story to delete task lists. Occasionally, you might make a task list in error, or you might find that you don't need one anymore and want to delete it. So we should allow users to do this. Then we have a user story here for capturing tasks. Each task list should have tasks associated with it, and that's what this user story sets out to achieve. Then we have a user story for updating tasks. Of course, once you've created a task, you might want to update it later, perhaps adjusting the title, the description, the due date, so on and so forth. Next, we have a user story for deleting tasks. You might make a task in error, so you might want to delete it. Now we have a user story for completing tasks. So this user story covers that requirement. Users should be able to mark tasks as complete. Next, we have a user story for the task completion progress. So users are informed of their completion percentage of tasks in a task list. If you've completed half the tasks in a task list, then you have 50% progress. And then next we have a set of bonus features, but we're not going to be implementing any bonus features in this particular project. But of course, feel free to implement any of these once we're done. So, with the requirements covered then, let's now move on to modeling our domain. A fundamental step in any object-oriented programming project is to define the objects or the domain that we're going to be working with. In this case, we only have the project brief to work from, but it happens to include everything that we need. So a simple but incredibly effective way to identify the domain is to go through the available documentation and identify the nouns, the things. They then become our objects and their instance variables. If we look through our task brief here, we can see several nouns popping up time and time again. We have task and we have task list, where the relationship between a task list and a task is contains. So that's to say, a task list contains tasks. If we dig a little further, we can see that a task list should have a title and an optional description. So some way of identifying it and then an optional description as well. If we scroll down a bit further here, we can see that each task should have a title, optional description, due date, and priority level. We also know, if we scroll down a bit further, that a task should be able to be complete. So a task can have a status of either complete or not complete. And while we're thinking about the state of things, we obviously have this priority that we mentioned before. So what's the priority of a task look like? So I'm going to assume that a task can either be a high, a medium, or a low priority. With this information identified, we now need a way of capturing it. So I've created here a domain model diagram, which captures all the core concepts and the relationships between them. So you can see here in this diagram, we've captured the task list and the task concepts and the relationship between them, which is contains. So we can see the title description, due date that was mentioned earlier as well. But perhaps what's a little new here is I've chosen to represent the task status and the task priority as enumerations, as enums. And we can see here we have a task status of either open or closed, and a task priority of either high, medium, or low. I've shown the relationship between task and task status, task and task priority as has. So that's to say a task has a status and a task has a priority. So this is a decent evolution from just picking out some words on a page, but it's missing some information such as types and the additional instant variables we would need to make a working system. So let's evolve this into a class diagram. So we can see this diagram shows the classes that we're going to implement for our domain. You can see it includes additional instance variables like ID. We also have this created and updated local date time as well. Because of course, each of our objects is going to have some identifier for it, and we might also want to know when that object was created and when it was last updated as well. Now I've chosen to use a UUID as the ID type, rather than using an ascending numeric sequence in the database. Now both would work, but UUIDs tend to be easier to scale. In these classes, I've also implemented the instance variables which demonstrate the relationships. So you can see here that we have the task list instance variable, which of course references this up here. We have task status, and we have task priority. If you've been taught the domain-driven design approach, you might be wondering why we've not chosen to model each class's methods in this diagram. Perhaps our task class should have a close method to move it from open to close status. So it should be noted that each class will have getter and setter methods, but I've omitted those from this diagram as it would simply clutter it, and perhaps confuse matters. However, as it's typical in a Spring Framework application, we're not going to place our business logic into our domain classes, but instead into service classes, but more on those later. So finally, for completeness, let's include an entity relationship diagram, or an ERD. This diagram shows how our domain or entities are organized and related in a relational database. So we can see the potential database table implementation along with the many-to-one relationship between task and task list. A task list will have many tasks. A task will belong to one task list. Although we could implement this in a NoSQL database, given the clear relationship, we'll use a relational database for this project. We're going to use PostgreSQL. So now that we understand the domain we'll be working with, let's explore what the user interface of such an application might look like. Now let's explore the user interface. As this project is focused on building the Spring Boot backend, we're not going to be going into the user interface design flow. Instead, we can jump right into the actual user interface, as I'm going to provide this for you. The user interface is an MVP, or minimal viable product. There are countless ways it can be improved, and you will certainly break it if you try. That said, it does meet the requirements on the project brief. So once we've started up our front end, we can see the task list screen. Clicking on the Create New Task List button gives us a simple form to create a new task list. If we give this one a title, a new task list, and perhaps a description, this is a description. And then if we click on Create Task List, we can see that we have a new task list here. Now if we click on that task list, we come onto the Tasks page. This also has buttons to both edit and delete our task list. So if we were to click on the Edit Task List button, we can update the name here, a newer task list, update task list, and we can see that we have a newer task list. The name has changed. We can also delete the task list, and that will delete it from our system. So let's try adding a task, which we can do by clicking the Add Task button here. We can give it a title, a new task, a description, and a due date. Let's choose the 1st of January. And then we can choose a priority. Let's go with high priority. And then we can create that task. And we can see here that we have a task associated with our task list. We can see its high priority and we can see its due date. We also have the ability to edit a task. Perhaps we want to change it from a new task to have title case like this. Maybe we want to change it to medium priority. Click on Update Task, and we can see that we've got an updated task listed here. We also have the ability to complete a task. If we click this tick box next to each task, then we can see that the progress bar fills up to full there because we've completed 100% of these tasks. If we add a second task, we can see here that it's only 50% because we've completed 50% of the tasks in this task list. Of course, we can also go ahead and delete tasks. So although the UI could use some additional features and polishing, it appears to meet the requirements as they've been set out. So with that covered then, let's explore the overall architecture of this project. So let's explore what the architecture of our application is to look like. We'll keep this simple and just stick to the components and how they fit together, rather than trying to describe how it might look once it's deployed to a production environment. The application we're to build has three main components. There's the database component, which will be using PostgreSQL, and we're going to run this in Docker to make things easy. Then we have our backend component. This is the Spring Boot application that we are to build. Then we have our front-end component, which is a React application that I'll provide for you. Of course, feel free to build your own application if you choose. There's nothing to say that you need to use my one. Although it's not standard UML, I've indicated that we'll use JPA in our Spring Boot application as a means to communicate with our database. The front-end component will communicate with the back-end component via a REST API. The REST API represents the interface between the front-end and the back-end. And considering we've already got a front end to work with, it's important that we implement the correct endpoints. So next, let's explore the design of the REST API that we're going to build. So let's explore the design of this REST API. If we start with our task list page here, we'll need a way of listing out all of our task lists and a way of creating task lists as well. We can provide that functionality with these two endpoints. Get task lists will list out our task lists, and a post to task lists will create task lists. Now let's go to our tasks page. So on this page, we'll need a way to edit a task list and delete a task list. Also, because of page refreshes and things like that, it would also be beneficial to get the details of one task list by using its ID. Now moving on to tasks, the task list page will need a way of listing out all of the tasks associated with a task list. We're also going to need a way of creating a task. We can provide that functionality with this set of endpoints. So we can see here the ones from earlier. We also have get task list by ID, update a task list, and delete a task list. And we can see the HTTP verbs get, put, delete. And then we can see the URLs here specifying task list ID in the URL. We can also see the first two endpoints for our task. Listing tasks, and then creating tasks. You can see that the task URL The prefix, the beginning bit here, is the same as what we have up here. So whenever we interact with our REST API, specifically for tasks, we're always going to provide the task list ID. And this is typical because a task list contains tasks. Of course, that's not our full set of endpoints, because once we've created a task, we're going to want to edit that particular task. And we may also want to delete that particular task. So the full set of endpoints ends up looking like this. We can see here that we basically have create, read, update, and delete endpoints for both our task list and for our task. For creates, we're using the HTTP post methods here, and we're not specifying the IDs in the URL for the objects that we are to create. We do specify the task list ID when we try to create a task, because of course tasks exist within a task list, so we need to know the ID of that task list. For reads, we're using the HTTP get methods here to either list out all of the objects that exist or to get a specific one via its ID. And that's true for both task lists and for tasks here. For updates, we're using the HTTP verb put, specifying the ID of the object that we are to update in the URL. Again, that's the same for task lists and for tasks. And finally, for delete, we're using the HTTP verb delete, specifying the ID of the object that we want to delete in the URL here. At this point, I think we have a pretty good idea of what we are to build. Let's get started by creating a new project. Let's set up a new Spring Boot project. By far the easiest way to do this is to use the Spring Initializer. So let's head over to start.spring.io in our browser. Here is where we're going to specify the configuration that we want our project to use and download a skeleton project using that configuration, which we can then use to build our task app. We're going to be using Maven in this project, so let's make sure we have Maven selected. And we're going to use the Java programming language, so let's make sure that's selected as well. If we scroll down, we can now select the version of Spring Boot that we want to use. We're going to select the latest general release version of Spring Boot, which at the time of filming is 3.3.5. You can tell if the version is a general release version because it usually doesn't have any letters after it. For example, it won't have snapshot, it won't have RC, it won't have the letter M next to it. It will just be a number, in this case, 3.3.5. Now, by the time you come to the Spring Initializer, there may be a higher number here. There may be a later version of Spring Boot. I just recommend using the latest general release version. The approach should be similar, if not identical, to the one that we're going to follow in this builder. But if you do get any errors, do reach out to the community. So next we're going to input our project metadata, and this is just there to identify the project. You can really put anything that you like in here. So I'm going to go with com Devtiro as the group. And for the artifact, let's call it tasks because it's going to be a task app. The description will just say a task tracking app. And the package name com Devtiro tasks is fine. And we'll select jar here. We won't select war, definitely jar. If we did select war, we would have to deploy our application to a separate running application container. So a separate running Tomcat, for instance. We don't want to do that. If we select jar, that's all bundled in, so we can just run the jar file and our application runs. So that makes our life a lot easier. Let's make sure jar is selected. Now for Java version, I'm going to select Java 21, which is the latest long-term support release at the time of filming. You're of course welcome to select a different Java version. If you come up against any errors, do reach out to the community. So with that selected, let's scroll up here, and now we can select the dependencies for our project. The first one that we're going to select is Spring Data JPA. And this will allow us to interact with our database by using Java objects. The next one that we'll select is going to be PostgreSQL. And this will allow us to interact specifically with the PostgreSQL database. The third dependency that we're going to need is the H2 database. Now, although we're going to be interacting with the PostgreSQL database, we're going to include this H2 database for our tests. And finally, we're going to select Spring Web as our final dependency for this project. In theory, we could select Reactive Web instead. This would allow us to use the reactive programming model to potentially get more throughput at a lower resource consumption. However, it would do so at the risk of a steeper learning curve and a more complex app. And really, as we're building a task app, we don't really need that throughput. So let's use the traditional Spring Web approach instead. So in summary then, we've used the Spring initializer, so that's start.spring.io, to create a new Spring Boot project. We've selected our key project configuration here, and we've added the dependencies that we need for our project as well, choosing Spring Web over Spring Reactive Web. So if we now click on Generate, that's downloaded the project that we can start building on. So next, let's open up our project in our IDE. So let's take a fresh look at this project. If you're unfamiliar with Maven, it's worth pointing out that most of this project structure is defined by Maven and not Spring Boot. You can see here that we have a Maven pom.xml, and we'll take a look at the contents of this file in just a moment. You'll also notice that we have some other files with MVN in the name. We have the mvmw file here, mvmw.cmd, and the .mvn directory. Together, this is a bundled instance of Maven that we can use to build our project, with the W standing for wrapper. So this is collectively referred to as the Maven wrapper, and it's the reason that we don't need to install Maven on our system. Now, if we wanted to use this bundled version of Maven to build our application, we can do so by opening up a terminal or a command prompt and then typing mvmw install. And we can see that we get a build success. Now, I'm running on a Windows machine here. If you're running on a Linux or a Unix machine, and macOS is an example of that, you'll need to run a slightly different command, and you can find that command in the builder's written materials. Now let's take a look at the contents of the pom.xml file here. So the first thing you'll notice is this parent node, Spring Boot Starter Parent, and the version 335. So this is where we specify the version of Spring Boot to use. And you'll notice 335 matches the version that we selected in the Spring initializer. If we scroll down a little bit, we can see here some project metadata, Devtiro, tasks, task, a task tracking app. Again, this is the same metadata that we entered in the Spring initializer. Scroll down a little bit further, and we can see here the Java version is specified as Java 21. Again, this is what we specified in the Spring initializer. And then we can see the dependencies that we've specified. Spring Boot Starter Data JPA, because we specified Spring Data JPA. Spring Boot Starter Web, because we specified Spring Web. There's our H2 database. There's our Postgres driver. And we've got the Spring Boot Starter test, which contains everything that we need to test our Spring Boot application. Now, we mentioned earlier that we're going to use the H2 database only in our tests. So I'm going to change the scope here from runtime to be test, and then click the refresh button. And what this means is that this dependency will only be available to use in our tests now. So if we expand these directories a little further here, we can see that we have this source main Java and then the package structure, source main resources, source test Java, and then that same package structure as well. This is the structure of a typical Maven project. In the Devtiro tasks package here, we can see the tasks application. If we expand that, we can see that this class has the @Spring Boot application annotation on the top here and contains a main method, which simply runs the Spring Boot application. As you can imagine, this is Spring Boot specific and not Maven specific. We open up our project directory once more, and then take a look at application.properties in source main resources. We can see a single property in here, spring.application.name and tasks. You see, we can use this file to configure our Spring Boot application. And at the moment, only the name of the application is configured. And that's what this property does here, naming our application tasks. If we open up our project directory again, and then let's take a look at this test class here. Now, this test class is annotated with the @Spring Boot test annotation here. So it's going to start up a test version of our application in order to run the tests against it. And we can see there's a single test in here with no content in the body. This simply tests that the Spring context loads, that our application starts up successfully. Now, it's worth noting that this is a builder and we're going to be focused solely on building. We won't be adding any unit tests to this application. However, we are going to make sure that our one test here continues to pass. Assuming that it does already pass, let's try that out. Great, so we have a passing test to begin with. That is a great first start. Now, let's see if our application runs. Let's open up our project directory. Let's go back to tasks application here. Now, let's click on this little green triangle to the left and click on run. Okay, let's expand that a bit further. And we can see here that our application failed to start. And there's two reasons for this. The first one is that it tried to connect to a PostgreSQL database, and we aren't running a PostgreSQL database right now. And the second reason is that we haven't provided the necessary configuration to tell our Spring Boot application where to find our Postgres database. And we will deal with this very shortly. However, in summary, we have ourselves here a Maven-based project structure with the Maven wrapper, MVMW, and our pom.xml file here. And that contains all of our key dependencies and configuration that we specified in the Spring initializer. In addition to this, we have ourselves a application.properties configuration file for our Spring Boot application, and we have a single test, task application tests. Our test currently passes. However, when we try and run our application, it doesn't run. And the reason being is that our application can't connect to a PostgreSQL database. So with that covered, let's start up a PostgreSQL database. Perhaps the easiest way to run Postgres is to do so in Docker. We've made sure that Docker is installed. Now let's make sure that it's running. We can do this by opening up a terminal or a command prompt and then running docker ps. We're expecting to see an empty list of running containers because at the moment we aren't running any Docker containers. That said, I'm currently getting an error here, and the reason being that even though that I've got Docker installed on my machine, it's currently not running. So you can usually run Docker from a start menu, application directories, things like that. So I'm just going to go ahead and run Docker now. And if we were to run docker ps once more, we can see here that we get an empty list of running containers. Even though this list is empty, it's exactly what we're expecting because Docker is running and able to give us a valid response. Next, we're going to create a Docker Compose file which runs Postgres. We'll use Docker Compose rather than using Docker directly, as it allows us to specify an environment of one or more containers, all in YAML. Not only is being able to manage our entire environment in one configuration file easier than using disparate Docker commands to set things up, you can check it into source control as well, so it's replicable across different developers' machines. So let's minimize this and then create in the root of our project a new file, and we'll call this one docker-compose.wml for YAML. And we'll populate this file with the following content. So looking over our docker-compose.yaml file here, we can see a single service called DB, with the Docker image being Postgres latest. We can see here that we're mapping port 5432 to port 5432. Port 5432 is the default Postgres port. This means that we can access it on localhost port 5432. We've got restart set to always, so if there's any problems, the Docker container will be restarted. And then we have a single environment variable called Postgres password. And this is how we specify to the Docker container what the password for the Postgres user should be. We can see here in this case, we have change me in prod ! And this will be the password that we specify in our Spring Boot configuration very shortly. Note that we're not specifying any Docker volumes here. This means that if we restart our Docker environment, we will lose all the data in the database. Obviously, not desirable in a production environment, but quite handy in a development environment. Now we can look to run our Docker Compose environment. So let's open up a terminal or a command prompt here, and we're going to run the command docker-compose up. At this point, Docker will download the Postgres latest Docker image if you don't already have it locally, and then run it ready to connect to on port 5432. So we can see here, the database system is ready to accept connections, and it's listening on port 5432. So our Spring Boot application should be able to connect to this on localhost port 5432. So in summary then, we made sure that Docker is running on our machine, and then we've created a Docker Compose YAML file. Within the Docker Compose file, we're running a single service called DB, and that will run Postgres. We've made it available on localhost port 5432, and we specified the password for the Postgres user. We've then gone ahead and run our Docker Compose environment, so we now have a running instance of PostgreSQL that our Spring Boot application can connect to. So next, let's update our application's configuration and have our app connect to PostgreSQL. When we tried to start our Spring Boot application earlier, we found it failed to start. The reason for this is that it couldn't connect to a PostgreSQL database. Since then, we've started a PostgreSQL database using Docker Compose. Now we have to tell our Spring Boot application how to connect to it. So in source main resources then, we have this application.properties file. In order to tell our Spring Boot application how to connect to Postgres, we're going to add the following configuration. This first property specifies for our application to use the PostgreSQL driver. This second one tells our application where to find the PostgreSQL database on localhost port 5432, connecting to the Postgres database. The Postgres database is almost always available on any running Postgres instance, so that's the one we're going to connect to. Next, we specify the username, which is Postgres, and then we specify the password. And you'll see here, this matches what we specified in our dockercompose.yaml file. This configuration is enough to connect to the database, but there is a missing piece of the puzzle. How are we to set up the database schema once we're connected? Do we create all the necessary tables, indexes, and sequences manually? This could get a little tedious, so let's add one more line to our properties file. This line will cause our app to automatically set up and even update the database schema to match the JPA entities that we'll create for our project, but more on that a little bit later. So with this configuration in place then, let's go back to our main method and attempt to run our application. Great, and we can see that our application has started. And we can see here we've got an added connection, PostgreSQL. So we can see our application has successfully connected to Postgres and is started up successfully. Now, whilst we're here, I mentioned that we'll not be using Postgres for our tests. We'll in fact be using the H2 in-memory database. Let's just revisit our test for one moment. So let's run our test again. Great, we can see our test still passes. Let's see what happens when we stop our PostgreSQL instance from running. I'm going to do that with Control and C on the terminal or the command prompt. Great, so we can see that stopped. So we no longer have an instance of Postgres running. Let's minimize that and let's try running our test once more. Okay, we can now see that the test fails. If we scroll down here, we can see that it's been unable to connect to localhost port 5432. So it seems like our test is trying to connect to our Postgres database. Of course, it's not really desirable for our test to try and use our production database, so let's add the necessary configuration in order for our test to use the H2 in-memory database. So let's minimize this, and let's minimize source main. Inside of source test, we're going to create ourselves a new directory here, and it's going to be called resources. So just like we have a source main resources, we're also going to have a source test resources. Inside of source test resources, I'm going to create a new file called application.properties. And it's within this file that we're going to add the configuration that our tests are going to use. So we can see the configuration is ever so slightly different from what we have in source main resources. Let's just take a look through these properties. So the first one specifies to use the H2 driver to connect to the H2 database. We next see the URL, and this is using H2 in memory. The database is called testdb, but that tends not to matter too much. And then we have some configuration specific to H2. Then we're specifying the username and the password to connect to the database. And then we're specifying here DDL auto create drop. So when our test runs, it will create the necessary schema in our H2 database and then drop it at the end. And then we have an extra bit of configuration at the end here to specify to use the H2 dialect, because of course we're using the H2 database. So with that done, let's now go back to our test and try running it once more. Great, and we can see the test passes once more. So in summary then, in source main resources, we've added the necessary configuration for our application to connect to our running Postgres database. In addition to this, in our source test resources, we've added the necessary configuration for our test to connect to our in-memory H2 database. We've seen that our test passes, and we've also seen that our application successfully runs. And with that, we have our running backend, a Spring Boot application. Let's now try to run our front end. To run the front end, you'll need the front end code, and you can download this from the Devtiro community site. Once you have the code locally, you can open up a terminal or a command prompt and then navigate to the directory containing the front end code. That's exactly what I have here. The first thing you'll need to do is install the necessary dependencies, and you can do that with the following command, npm install. Once everything is installed, you can run the app by running npm run dev. And all that's left to do now is to open up our browser on localhost port 5173. Now here we have our running front end. Now as a useful experiment, let's just flip back to our IDE once more. Let's go back to the tab that was running Docker Compose and let's run that once more. So we now have our database running. Let's now go up here and just restart our backend. Great. Okay, so our backend is running once more successfully. That's all good. Let's now go back to our front end. Now let's open up a networks panel. I'm going to do that by right-clicking, going down to inspect here, then going to network. And this is going to show us all of the requests made from our front end to our back end. Let's click on create new task list. And let's give this one a name. Anyone will do. And let's do the same for the description. And then let's click on create task list. So we can see that nothing's happened. We're still on the same page. The request failed with a status code of 404. We can see the request has been sent here. We've got that 404. And the reason for that, of course, is that we haven't implemented this endpoint on our backend yet. So the first step for us to implement these endpoints is to implement our domain. Let's do that next. Now that we have our basic Spring Boot application set up and connected to a PostgreSQL instance, let's start implementing our domain model, beginning with the task entity. First, let's create a new package structure to contain our entities. We'll right-click here. We'll go New, Package. And the package structure we'll create will be com Devtiro tasks domain.entities. And this is where we'll store our entity classes. Before we create our task entity, we'll need to create several enums that will support our task entity. So let's start by right-clicking in the package, go New, Java class, and we're going to create the task status enum. So let's select enum instead of class. Let's double-click. So if you remember our domain model from earlier, we need some way of representing whether or not a task is open or closed. So we're going to add these two values to this enum. Open, closed. And that's all we need to do in this enum. So let's go back to our project structure. And we're going to create a second enum. So we'll right-click in the same package, go New, Java class. And this one will be called task priority. And again, this will be an enum. We need some sort of way of representing the priority of a task. Is it high priority, medium priority, or is it a low priority task? So we're going to add those three values to this enum. High, medium, low. And that's all we need to do in this enum. So let's go back to our project structure. And now in our entities package, we'll create a new Java class called task. And this one will be a class. So the first thing that we need to do to mark this class as a JPA entity is to add the entity annotation to the top of the class. Next, because we're relying on AutoDDL to set up our database schema for us, I'm going to add the table annotation here, which allows me to specify the name of the table that will then be created in the database. And I'd like the table tasks to be used in this case. Now we get to create the instance variables that will map to the columns in the database, starting with our ID instance variable. Private, this will be a UUID type, and we'll call it ID. Now in an entity, you mark the ID of that entity with the ID annotation. So let's do that first. Now we're using a UUID for our ID. It would be really nice for JPA to generate UUIDs for us when it finds their null. So if we go to create a new task and the ID is null, rather than us have to manually generate a UUID, it would be nice for JPA to do that for us. And the way that we specify that is by adding the @generated_value annotation with the strategy of generation type UUID. So every time that we create a task with a null ID, JPA will generate for us a new UUID, and that will be the value of the ID instance variable. Next, I'm going to specify the @column annotation. And in a similar way to how the @table annotation allows me to specify the name of the table that will be created in the database, the @column annotation allows me to do that for the column. So we'll add a name argument here, specifying ID. Now it should be noted that the default name for the column will be the same as the instance variable. So in this case, this doesn't add a lot of value. However, the column annotation has other arguments. Updatable, false. Nullable, false. So this allows me to specify that ID should not be updatable. It also allows me to specify that ID should not be nullable. In this way, once an ID is created, it cannot be changed, and there will never be a case where an ID is null. A task will always have an ID value. So with that done, let's now move on to the title, which will be a string type called title. We'll add the column annotation to this one too, specifying the name of title, and nullable equals false. We always want a task to have a title value. We never want it to be null. Now you may have noticed that we're missing the updatable argument in here. And the reason for that is updatable, the default is true. And we want titles to be updatable. So we can actually omit this. So that's title done. Let's now move on to description. This again is a string called description. And we'll add the column annotation up here. The name description. And now I'm going to also omit nullable because the default value for nullable is true. And description is actually optional. You don't have to provide a description when you create a task. So let's delete that. And that's our description instance variable. Next, we'll do due date. So private, this will be a local datetime type called due date. We'll add the column annotation here. The name will be due_date, and we'll omit nullable and updatable. We'll just use the default values for those. Now you might wonder why we're using an underscore in this case. Well, this is snake case, and this is the convention that you'll typically find when you name a database column. In contrast, this is camel case, which we typically use when we name an instance variable of a class in Java. So now we get to use those enums that we created. Private, task status, and we'll call that one status. We'll add a column annotation, and the name for this one will be status, and nullable will be false. We always want a status to be provided whenever we create a class. Next, we'll create an instance variable for our task priority. We'll call this one priority, and we'll add a column annotation here. The name will be priority. And again, this will be nullable equals false. We always want a task to have a priority. And now we'll create several instance variables for some order information, starting with the private local datetime created. And this will be when the entity is created in our database. We'll add a column here. The name we'll use created. And nullable is false. I'd also like to know the last time that this entity was updated. So I'm going to create a private instance variable, local datetime, updated. @column, the name of this will be updated. And again, nullable equals false. When a task is created for the very first time, the value of created and updated will be the same. So that's all of the instance variables our class needs right now. So next we're going to create the constructors for our class. And there's several ways of doing this, but we're just going to rely on the IDE to generate them for us. So let's right click, go to generate, constructor, and then I'm going to go select none. I want a no arguments constructor to begin with. Then I want an all arguments constructor. Generate, constructor, and then we'll select all and then go OK. And then we have an all arguments constructor generated. Next, let's generate the getters and the setters. Right click, generate, getter and setter. We'll select all and then go OK. And we now have a getter and a setter created for every single instance variable. Now let's create an equals and a hashcode method. Right click, generate, equals and hashcode, next, next, create. And there's our equals and hashcode. And finally, let's generate a toString. Great. So let's just take a look at what we have here. Looking good. However, what I am going to do is just right click on the all arguments constructor here, go to refactor, change signature, because I always find having the ID as the first argument is most helpful. And let's move the task priority down to be in roughly the same order that it is in the class. Next to status should do, refactor. There we go. Now ID is specified first. That's just personal preference. So just a quick note on local datetime, which is this type right here. We're using local datetime for our datetime fields because it's the modern Java way to handle dates and times. It doesn't carry any time zone information, but for this app, we don't need it. And it's well supported by both JPA and JSON serialization, which we're going to be using both when we build our app. So in summary then, we've created several classes. We have ourselves a task status enum, which represents open and closed. We have a task priority enum, which represents the task priority of high, medium, or low. And then we've created our task entity with all of its instance variables, all of the constraints specified, constructors, getters, setters, equals hashcode, and toString method. So we've created our task entity. Next, let's create our task list entity. So now that we have our task entity created, let's create the task list entity, which will represent a collection of tasks. First, we're going to create a new class in our entities package here, new Java class, and we'll call this one task list. And this will be a class. Again, as this is an entity, let's add the @entity annotation to the top there. And let's add the @table annotation, specifying the name of task lists. Again, using snake case there. Just like in our task entity, we'll start with the ID, which will be a UUID type called ID. We'll add the ID annotation. We want JPA to generate these for us, so we're going to use generated value with the strategy of UUID. And then we'll use the column annotation to specify the name is ID, updatable is false, and nullable is false. So next we're going to create the title and the description instance variables. Private, string, title. We'll add a column annotation to the top, specifying the name of title, and nullable is false. We always want a title provided. Next, we'll do description. Private string description. We'll add a column annotation to the top, and the name will be description. This one is optional, so we'll omit nullable equals true. Now let's specify the created and updated instance variables. Private, local datetime, created, @column, and then we'll specify the name, which is created, and nullable equals false. Next, we'll do the updated local datetime, updated, and the column annotation where the name is updated and nullable equals false. Like our task entity, we'll need to generate constructors, getters, setters, equals, hashcode, and a toString method. However, we're not going to generate those right now. You may have noticed, but we've not referenced task anywhere in our task list class. And this might strike you as odd because task list is there to model a list of tasks. So next we're going to focus on setting that relationship up between task and task list. But before we do, a very quick summary here. We've created ourselves a task list class and we've created instance variables for ID, title, description, created and updated, specifying the constraints that we want in the database, And now we're going to set up the relationship between task and task list. Now that we have our basic task and task list entities, let's set up the relationship between them. Looking at our domain model, we can see that a task list contains many tasks, and each task belongs to exactly one task list. So first, let's open up our task list class here and add a reference to that collection of tasks. So just after the description instance variable here, I'm going to create a new instance variable. It's going to be a list of task, and I'm going to call this one tasks. Let's import list. Next, I'm going to add the annotation one to many. And this represents one task list to many tasks. Inside of this annotation, I'm going to specify the mapped by argument here and provide the value of task list. And this is going to be the instance variable that we're going to create on our task class in just one moment. And it will be that instance variable that contains more configuration. And that's what mapped by is for. It basically says, look for the instance variable task list on the task class for more information about this relationship. Next, I'm going to specify the cascade argument, and I'm going to specify two cascade types. The first one is going to be remove, and the second one is going to be persist. Let's format this. What this means is that when we delete a task list, all of the tasks will be deleted too. That's cascade type remove. It also means when we save a task list, any new task it contains will be saved too. That's cascade type persist. So we've added our list of tasks to our task list class. Let's now go over to our task class. Let's scroll up to the instance variables. Now, just under priority, just before created and updated, I'm going to create a new instance variable. And this one is going to be of type task list. And we'll call that one task list. You will notice that this name matches what we specified in the mapped by argument here. On the top of the task list instance variable, I'm going to add a couple of annotations. The first one being many to one. You'll notice that this is the inverse of the annotation that we've placed on task list. Here it's one to many on task list, and on task it's many to one. In the arguments to many to one, I'm going to specify fetch, and that's going to be fetch type lazy. What this means is that the task list won't be loaded from the database until it's actually needed. And now for a second annotation, it's going to be at join column. And we'll specify the argument of name, and we'll use for this task list ID. And this specifies the foreign key column name in the tasks table. Or put another way, it will be the column in the task table that contains the ID of the task list to which the task belongs. So with this new instance variable added, we need to update our constructors, getters, setters, equals hash code, all of this boilerplate code. So to make things easy, I'm going to delete everything that we have here. And I'm going to follow exactly the same process that we did before, starting with the constructors. There we go. So we've just generated a new toString, equals and hash code, getters and setters, and then we have an all arguments constructor and a no arguments constructor. Again, I'm just going to update the signature for this one, refactor, change signature, and just move ID to the top there. And we'll move task list down to near the bottom. There we go. Again, just personal preference. So that's this iteration of the task class complete. Let's now go to the task list class and generate the constructors, getter setters, equals hash code, toString. And there we go. We have a toString method, hashcode equals getters and setters for each of our instance variables, an all arguments constructor, and a no arguments constructor for our task list class. Just a quick note on the type of relationship that we've set up here. It's technically known as a bidirectional relationship because when we load a task list, we can access its tasks, and when we load a task, we can access its task list. So in summary then, we've added a one-to-many relationship in our task list to manage its tasks. We've added a many-to-one relationship in task to reference its task list. We've configured cascading to handle the task lifecycle with its task list. And we've updated all of the boilerplate code for both the task list and the task classes, so they're now ready to use as entities. With our entities and their relationship now properly set up, we can move on to creating our DTOs. Now that we have our task and task list entities set up, we need to create data transfer objects, or DTOs, to represent these entities in our REST API. DTOs help us to separate our domain model from our API contract and give us control over what data we expose to clients. So let's start with our task DTO class. But I don't want to create that in the entities package, so I'm going to create a new package, and we'll create this inside of domain, and we'll call this one DTO. And it's in here that we're going to create our DTOs, and in this way we can keep them separate from our entities. So let's right click, go new Java class, and we'll call it task DTO. However, it's not going to be a class, but a Java record. We'll use a Java record for this as it provides a concise way to create an immutable data class with all of the boilerplate code we need. So let's declare which instance variables we want to expose in our task DTO, starting with the UUID ID. Let's import UUID. So we definitely want the task DTO to have an ID. Next, let's do a string title, string description. We also want the due date to be exposed, so local date time, due date, and let's import local date time. And we'll also want to expose the task priority, which we'll call priority, and the task status, which we'll call status. Just need to import that there. Notice what we've left out compared to our task entity. There's no created or updated timestamps, as these really are internal concerns. You'll see there's no task list reference. We're going to handle this relationship through URLs in our REST API, but more on that later. Also note that there are no JPA annotations. DTOs are simple data carriers. And by using a Java record, Java automatically provides us with constructor for all fields, getter methods using the component names, and you'll see those used a little bit later, equals and hashcode methods, a toString methods, and immutability. You'll notice that I didn't say setter, only getter, because each of these instant variables are immutable. So we can now use our DTO to accept task data from API request and return task data in API responses. So in summary then, we've created the task DTO record to represent tasks in our REST API. We've included only the fields that we need in the API contract, and because we've used a Java record, we automatically get getter methods and immutability, and we've excluded internal implementation details like timestamps and JPA relationships, as they're just not needed. So we have our task DTO, let's now implement our task list DTO. Now that we have our task DTO, we need to create a DTO for our task list. Like with our task DTO, we're going to use a Java record to create an immutable data class that represents a task list in our REST API. So within our DTO package, let's right click, create a new Java class, and we'll call this one task list DTO. And this will of course be a Java record. So just like our tasks, we're going to expose the ID, which is UUID type, the title, which is a string type, the description, which is also a string type, and this is where it gets interesting. We're also going to expose the count of tasks in our task list, which is going to be an integer type, and we're also going to expose a double of progress, which represents as a number between 0 and 1 how many tasks in our task list have been completed. And finally, we're going to expose a list of task DTO, And we'll call this one tasks. Let's import list and remove that. So we've included all of those basic identifiers like ID, title, and description. We also have a list of those task DTOs here. Notice that we're using a DTO, task DTO, within our task list DTO. We're not using the entity. And we've also included a couple of computed fields, count and progress. We've also excluded the created and updated timestamps because, like with task, these are internal concerns. We haven't put any JPA annotations on here because DTOs are just there to carry data, and there's no relationship management, nothing like that. That's all handled at the entity level. So now that we have both our entities and our DTOs, let's handle how we map from one to the other and back again. Now that we have our task entity and task DTO classes, we need a way to convert between them. This is where mappers come in. They handle the transformation of objects between our domain, entities, and our presentation, DTOs. Whilst we could perform these conversions directly in our service and controller classes, using dedicated mapper classes gives us several benefits. We have a separation of concerns, that mapping logic is isolated and reusable. We have consistent transformation rules across our entire application. Arguably, it's easier to maintain and modify that mapping logic, and it should give us cleaner service and controller code. As this is a fairly common approach, several libraries exist, such as MapStruct, which will automatically do the mappings for us, but we're not going to use them this time. We'll manually implement our mappings. So let's create a new package, and we'll do that in com Devtiro tasks. I'm going to call that one mappers. And within mappers, I'm going to create a new Java class, and we'll call this one task mapper, but it won't be a class, it will be an interface. And we'll use an interface because it's best practice to code to interfaces rather than concrete classes. Now, to define the contract of this interface, we're going to have a method called from DTO, which takes a task DTO and it will return a task. Let's just import these. And it's going to have a second method, which is called toDTO. And this will take a task and it will return a task DTO. And that's our interface complete. So let's now implement this. So within the mappers package, I'm going to create a new subpackage called impl, IMPL. And this is a convention that you'll see in certain places, and it just allows us to separate the implementations from the interfaces. Within of impl, I'm going to create a new Java class, and I'm going to call this one task mapper impl. And we'll say it implements task mapper. Now you notice we have this red squiggly line, and that's because we've declared some methods in the task mapper interface which don't exist in the task mapper impl class. So if we were to click on implement methods now, we get a couple of method stubs. Of course, they both return null, which isn't very helpful, but it does make the red squiggle go away. So now let's implement these methods, starting with from DTO. So this is going to return a new task. And now we need to use the all arguments constructor, populating it with values from our task DTO. The first one being the ID. So we're going to say task DTO dot ID. Notice it's not get ID, just ID, the method. And that's the convention used by Java records. Next, it's title, then description, then due date, then status, then priority. And then we have our task list, our local date time, and our updated date time. I'm just going to specify these as null. Let's put a semicolon there. So that's our from DTO implemented. Let's now do our to DTO. So let's create a new task DTO. And now we'll go the other way. Task.getID, task.getTitle, getDescription, getDueDate, getPriority, and getStatus. And that's our toDTO method implemented. Now, we're going to want to inject this class throughout our application wherever it's needed. So I'm going to place on the top of this class the @component annotation. The @component annotation marks this as a bean. It would inject any dependencies that we declare for this class, of which there aren't any, and it will also make this class a candidate for injection wherever it's declared throughout the application. And you'll see that used a little bit later. So in summary then, we've created a task mapper interface, which specifies the from DTO and to DTO methods. We've then created an implementation of our task mapper impl, which implements those methods going from DTO and to DTO. We've also put the @component annotation on the top of task mapper impl, so we can inject it wherever we need it throughout our application. Now that we've implemented our task mapper, let's implement our task list mapper. Now that we have our task mapper implemented, let's create the mapper for task list. This mapper will be more complex than our task mapper, as it needs to handle the collection of tasks and calculate some derived fields like count and progress. So first, let's create the task list mapper interface in our mappers package. New Java class. We'll call it task list mapper, and we'll make sure it's an interface. Just like with our task mapper, we're going to have a from DTO method. It's going to take a task list DTO, and it's going to return a task list. We're also going to have a to DTO method. This one's going to take a task list and return a task list DTO. Okay, that's the interface done. Let's now create the implementation for this. So I'm just going to copy this class name, go over to the implementation directory, go new Java class, and we'll call this one task list mapper impl. And this will be a class. And let's expand that. So this implementation is going to be more complex because we need to handle the conversion of the task collection, calculate the task count, and calculate the progress. So it's all going to start by implementing the task list mapper. Let's now implement those method stubs. Great, so let's start with from DTO. So this is going to return a new task list, and now to populate it. Task list DTO, ID, task list DTO title, task list DTO description. Now we have to deal with this list of tasks. So let's start with an optional of nullable to handle the case where it could be null. And we'll pass into that task list DTO dot tasks. So in the case that it's not null, we'll call tasks dot stream dot map. And now we need a way of converting from a task DTO to a task. And for that, we're going to use the task mapper. So we need to inject it into this class. So let's declare a private final instance variable of task mapper. And if we hover over this, we'll add a constructor parameter. Of course, we don't have a constructor right now, so it's created one for us. And it's through this constructor that our task mapper will be injected and available to use. Of course, we are going to have to put the @component annotation on the top here to declare task list mapper impl as a bean and to allow dependencies to be injected. So now that we have our task mapper, we can convert from a task DTO to a task. I'm going to do that by going task mapper from DTO. So we've taken that list of task DTOs and then we converted each one in turn from a DTO into a task, but we're still left with a stream at the moment. So let's convert it to a list. So we've dealt with the list of tasks. However, we do have this optional of nullable in play. So we've done this map function here. Let's deal with the case where it is in fact null. So we'll do that by going or else, and I think we'll just return null. And now for created and updated, our DTO doesn't have this information, so we're just going to specify null in this case. Great, and that's our from DTO method implemented. Let's now move on to our to DTO method. So this one's going to return a new task list DTO. And the start is fairly straightforward again. We're going to say task list, get ID, get title, get description. And now we come on to calculating the count. So the count is literally how many tasks are linked to a task list. And we can calculate that by, we'll use optional of nullable again. just to handle the case where we could come across a null. And we'll say task list dot get tasks. So let's call a map function to handle the case where it's not null. So we actually have a list of tasks. And then we'll simply call list and then size. And to handle the case where our task list is in fact null, well, there certainly isn't going to be any tasks in that list. So we are going to go or else and return 0. Now we're to calculate the progress. Let's create a new private function for this one. Private. This will return a double. And let's call it calculate task list progress. And this is going to need a list of tasks. Let's just import task. Great. So let's first handle the case where that list of tasks is null. So we'll say if null equals tasks, we're simply going to return null. In order to work out the progress value, we're going to have to work out how many of the tasks in our list here are in fact closed. They have the closed status. So let's work that out. Let's go tasks.stream, and then we'll filter. And we'll filter for task status dot closed equals task dot get status. And we simply want the count. So let's call the count method on there. Let's just put this on a new line to break it up a little bit. And let's assign this to a variable called closed task count. So this should give us the count of all of the tasks in our list that are in fact closed. They have that closed status. Now we can calculate our progress value as follows. We'll return the closed task count and we'll divide that by tasks.size. Of course, we'll need a double in this case rather than a long, so let's return a double. And we can do that just by casting here. Not a very refined implementation, but it will certainly give us a value that we can then use on our front end. So let's now use this up above here. And in order to get the progress value, we're going to call calculate task list progress, passing in our list of tasks. So task list dot get tasks. And now we need a list of task DTOs. So we're going to optional of nullable, get the list of tasks from task list. Now in the case that we do have a list of tasks, .map, we'll say tasks.stream.map, and then we're going to convert them. So task mapper, and then we'll call this time toDTO. And finally, we're going to call toList. Let's just break this up a little bit. And now to handle the case where optional of nullable is null, we'll call or else, and we'll just return null in this case. Great, and that is our toDTO method implemented. So in summary then, we have created ourselves a task list mapper interface, and we've then implemented that interface over in task list mapper import. We've created a class which implements task list mapper, and we've put the @component annotation on the top to mark it as a bean to make it available for injection, and then also have its dependencies injected. We've then implemented the from DTO and to DTO methods, and we've noted that the implementation of these methods is more complex than what we had over in task mapper because we have to calculate the progress and the count. And with that, we've implemented the entities, DTOs, and mappers that we're going to need for our application. Now let's move on to our repositories. With our entities and mappers in place, we now need a way to persist and retrieve task list data from our database. In Spring Data JPA, this is done through the repository interfaces. So let's create a repositories package over here. So we're going to right click, go new, package, and we'll call this one repositories. And within the repositories package, I'm going to create a new Java class, and I'm going to call this one task list repository. However, it's not going to be a class, but an interface. So let's maximize that. So in order to create a repository, we need to do a few things. And the first thing is to add the repository annotation to the top of our interface. The second thing is to extend a repository parent. In this case, we're going to extend JPA repository. JPA repository is going to give us all of that CRUD behavior, allowing us to create, read, update, and delete from the database for our chosen entity, and it also has some querying and paging behavior in there as well, but we're not going to be using that for this project. Now we specify the type of the entity that we're dealing with. In this case, it is task list. And now we'll specify the type of task list ID, which we know to be the UUID type. And with that, we've completed the implementation of our task list repository. Yes, it's just an interface, but Spring Data JPA is going to provide the implementation for us, making available methods like save, find by ID, find all, delete by ID, and many more. So now that we have a repository for dealing with task lists, let's now create a repository for dealing with tasks. So now that we have our task list repository, let's create our task repository. So in the repositories package here, I'm going to create a new Java class and call this one task repository. And this is going to be an interface. As this is a repository, I'm going to add the repository annotation to the top here. And then I'm going to extend a parent repository. And in this case, we'll go with JPA repository once more. We'll now specify the type that this repository deals with. In this case, it is the task entity and the task entity's ID type, which we know to be UUID. So just like with our task list repository, this implementation makes so much behavior available to us. However, we're going to need some custom queries for our task. And to do that, we're going to define two methods in this interface. The first one's going to return a list of tasks. Let's import list. And we'll name this method, and the naming is very important here, find by task list ID. And then we'll specify a single argument of UUID type called task list ID. We'll use this method for getting a list of tasks by the task list ID that they're related to. And now for our second method, and this is going to return an optional of task. So if it finds a task that matches, it will return it. Otherwise, we'll get an optional empty. And we'll name this one find by task list ID and ID. And we'll provide two arguments to this one. The first one, a UUID type called task list ID. And the second one, a UUID type called ID. So this one looks for a single task where the task list ID and the task's ID matches. So I mentioned that the naming of these methods is very important. By adding methods with a particular naming structure inside a repository, Spring is actually going to work out what the query should be for us. So we can see here, find by task list ID. Well, we know that a task has an instance variable called task list, and we know that task list has an instance variable called ID. And we also know that we have a single argument called task list ID. With this information, Spring Data JPA can work out that query. Slightly more complex, but the same is true for this method, find by task list ID and ID, because of course we know that a task has an ID instance variable. So in summary for this one then, we've created a new repository, extending JPA repository. And for this, we've created two custom queries, find by task list ID, find by task list ID, and ID. So with our entities, our DTOs, mappers, and now repositories created, we can start implementing our first REST API endpoint. Now that we have our domain model, DTOs, mappers, and repositories set up, let's implement our first endpoint, listing task lists. We'll need to create both the controller and service layers to handle this functionality. First, let's create a new package, and we'll do this one in com Devtiro tasks, and we'll call it services. Within the services package, I'm going to create a new Java class. I'm going to call this one task list service. But it's not going to be a class, it's going to be an interface. So the interface only needs to define a single method at the moment, and that's going to return a list of task lists. Let's import list, and we'll call the method list task lists. So with that done, let's create an import package in our services package. Now let's create an implementation for our task list service. So let's create a new Java class in the import package, and we'll call this one task list service impl. And this one is a Java class. So first, let's declare that it implements our task list service. And now we get that red squiggle. So let's implement those methods. Only a single method. And there is list task lists. Now, before we forget, let's put the @service annotation on the top of this class, declaring it as a bean, and then injecting any dependencies that we declare. We're going to need a single dependency, and that's going to be our task list repository. So we'll declare a private final task list repository, and we'll call this one task list repository. And then if we hover over this, we'll add a constructor parameter. Great, and that will inject our task list repository ready to use in this class. So how are we going to use it? Well, inside of the implementation for list task lists, let's remove list of, and we'll replace that with task list repository dot find all. And that's simply going to return a list of task lists, every single task list in the database. And that's all we need to do in our service for the moment. So let's now move on to our controller. So let's create a new package for our controllers. And we'll do this one in com Devtiro tasks, and we'll call it controllers. And within that package, I'm going to create a new class, and I'm going to call this one task list controller. And that's going to be a class. So first, this is going to be a REST controller. So we'll add the REST controller annotation to the top of the class. Now I'm going to declare the path that this controller is going to operate on. And I can do that with the request mapping annotation. And inside of there, I'm going to declare the path as task lists, which is what we had from earlier when we designed our REST API. We also declared that the list task lists should be a get method. So let's declare that, get mapping. And then we'll declare a public method that returns a list of task list DTOs. Note that it returns a DTO and not a task list entity. It's import list. And we'll call this method list task lists. So it's this method that will respond when we do a get call to /task lists. So how do we implement it? Well, first we're going to need to get a list of task lists, and then we need to convert them into a list of task list DTOs. So we're going to need two dependencies for that. Let's declare them up here. We're going to need a task list service, which we'll call task list service. And we're going to need a task list mapper, which we'll call task list mapper. And if we hover over these, we'll go add constructor parameters, and that will declare for us a constructor. Perfect. So dependency injection works in the same way in this class as it does throughout our application. The @REST controller annotation marks this class as a bean and also injects any dependencies that we declare, in this case, the task list service and the task list mapper. So let's use our dependencies and let's get a list of task lists to begin with. So we'll go task list service dot list task lists. And now we need to convert this list of task lists into a list of task list DTOs. And we'll do this by calling stream, which we'll place on a new line, dot map, and we'll use the task list mapper, and we'll call toDTO. And then we have a stream at this point, so we'll convert it back to a list, and we'll return this. And that's all we need to do on our controller. So typically what happens is when we get a HTTP GET request to /task lists, it will map to this endpoint method here. It will then call our task list service, getting a list of task lists, to which we will then process each one in turn using map, converting it from a task list to a task list DTO, and then returning it as a list of task list DTOs to the caller. So let's try out our application. Let's make sure Docker Compose is running. Docker-compose up if it's not. So there's our database running. Let's now run our application, our backend. Great, that's the backend started up successfully. And now we'll just run our front end, which we'll do with npm run dev. So with our backend and front end running, let's now test out this endpoint and see if it works. So let's head over to this address in our browser. So here we are on the list task list page. Now, if we go to our inspect and go to our networks panel once more, I'm just going to refresh this page. Great. So we can see when you hit this page, we get a GET request sent to task lists, which is the endpoint that we've just implemented. We can see rather than a 404, we get a HTTP 200, which is great. That means that our backend has actually sent a response, and the response that it sent is pretty unclimactic. It's just an empty list because we currently don't have any task lists created in the database, but this does mean that our endpoint appears to be working. So in summary then, we've created ourselves a task list service interface with a single method on there, list task lists. We've then created a class to implement that and implemented our list task lists by calling our task list repository find all, giving us all task lists currently in the database. We've then used our service in our task list controller, which we've also created, defining a single endpoint for the time being, a HTTP GET request to /task lists. We've then used two dependencies in this class, the task list service to give us a list of task lists, and then the task list mapper to convert that list of task lists into a list of task list DTOs before returning it to the caller. And we've used our front end to try out our endpoint, but currently it only returns an empty list. This is a great achievement, but it would be a lot better with some data. So let's move on to the create task list endpoint. Now that we've implemented our list task list endpoint, let's implement the ability to create new task lists. We'll need to add methods to both our service and controller layers to handle this functionality. So let's head over to the task list service. And to this, we're going to add another method. This one's going to return a task list, and we'll call this one create task list. So it's going to return the task list that we've created. But in order to create a task list, we're going to pass in a task list to create. So we've added a new method to this interface, which means if we head over to our implementation here, we have that red squiggle once more. And the reason being, we have a new method to implement. Let's implement that. So at the moment, it just returns null. Let's change that. So this method is to be used exclusively to create task lists. What that means in practice is that any task list that's passed into this class must have a null ID. It must be a new task list. And then once we create it, it will receive an ID. So let's just do a quick bit of validation before we start. So we'll say if null does not equal task list.getID. So that's to say, if task list does not have a null ID, then we're going to throw an illegal argument exception. And we're going to say the task list already has an ID, and it's throw new illegal argument exception. Let's just expand this, and we'll put a semicolon at the end there. Now, the next thing I want to validate for is to make sure that our task list has a title. So I'll add another if statement. If null equals task list dot get title, or task list dot get title dot is blank, then we will throw a new illegal argument exception and we'll say task list title must be present. By doing this validation, we can make sure that any task list that we attempt to create in the database will in fact have a title. Remembering that we set up a constraint earlier that any task list that we do try to create must have a title. Otherwise, we're going to hit that constraint. So let's now use our task list repository and we'll call save on this. And now I'm going to create a new task list inside of here. By creating a new task list instance rather than using the input passed into the method, we ensure that no unexpected data gets persisted in the database. So we're going to rely on the database to generate an ID for us. So we'll pass in null for the ID. The title will come from our task list.getTitle, as will the description, task list.getDescription. Now, this task list won't have any tasks associated with it at the moment, so we'll pass in null to there. And now we have to provide the created and updated date time. Now, we happen to know that they're both going to be the same time to begin with. So let's create a local date time called now, and this will simply be local date time dot now. which will be the time and date right now. Let's pass it in for both created and updated. Semicolon. And we'll return this. Removing this line. There we go. So our create task list method then will make sure that the task list pass in does not have an ID, because this is for a create and not an update. We then make sure that the task list passed in has a title, which is what we're expecting. We don't ever want a task list in the database created with a null title. If either of these cases fail, then we'll throw an illegal argument exception. We then create a new task list, which we save to the database using the information from the task list passed into this method. We then return the task list that we created in the database. So with our new method added to our service, let's now add a new endpoint to our controller. So let's open up our project directory. Let's open up the controller's package. Let's go to our task list controller and let's expand that. So let's add a new method to this controller. Now we happen to know that create task list is going to use HTTP post. So we'll define the post mapping annotation there. This method is going to be public and return a task list DTO, the task list that was created in the database. And we'll call this method create task list. Now our front end is going to send a representation of our task list to be created, and that's going to be the task list DTO. So I'm going to define a @request body of task list DTO, and we'll call that one task list DTO. So when our front end sends in the body of the request a representation of a task list DTO, this will allow us to access that and use it within our method. Let's now look to create our task list, and we can do that by calling task list service dot create task list. And this method requires a task list rather than a task list DTO. So we'll call our task list mapper from DTO, passing in the task list DTO, task list, created, task list. Of course, this method requires a task list DTO returned. So we'll say return task list mapper dot to DTO created task list. So the implementation of this method then, we take the task list DTO that was passed in the request body, we convert it into a task list, and then we use that task list to create a new task list in the database via our task list service. That will return the task list that was created. So we then convert that to a task list DTO, and we return that to the caller. So let's try out our new endpoint in our front end. So let's restart the backend application here. That seems to have restarted. So let's now head over to our front end. So here we are back on our front end. So let's just pull the networks panel down just a bit. And let's click on the create new task list button. So this form will allow us to create a new task list. So you can see there's the title, there's the description. So we'll say a new task list. The description will just say, this is a description. Let's just clear out our networks panel and let's click on create task list. Great. So we can see the request went through. We got a HTTP 200 returned. Let's just take a look at that request and the response. So we can see the request that our front end passed to our back end with the title, a new task list, and the description, this is a task description. This is what our back end will then look to put into a task list DTO ready to use in our endpoint in our controller. This is the representation of the task list DTO that our controller will then use. If we take a look at the response, we can see that the response, first of all, has an ID. This is a UUID that's been generated for us by JPA. We can see the title that we passed in, a new task list. Description, this is a task description. The count is 0. Progress is null, and tasks null. Arguably, it would be nice to maybe have the progress set as 0, but either way, it works as expected. Because if we pull this down here, we can see that not only were we able to create a new task list, but our list task lists is now listing it out. We can see it right here, a new task list. So in summary then, we added a new method to our task list service called createTaskList, which takes a task list and returns a task list. And it's the job of this method to create task lists in our database. Because we added a new method to this interface, we then had to add a new method to the implementation, which we can see inside of task list service impl. Inside of this method, we first validated the task list passed in, and then we use that to create a new task list that we then saved to our database. We've done it this way to ensure that no unexpected data gets persisted. With our new method implemented, we then went over to our task list controller and we added a new method. This one, a post mapping, HTTP post, called createTaskList. This one takes a task list DTO in the request body. It then uses that task list DTO to, first convert it into a task list, and then pass that to our task list service to create that task list in the database. And then the created task list that's returned, we then convert that back to a DTO and then return that to the caller, which in this case is our front end. And we've seen that working in our front end as well. Not only the create endpoint, but also the list endpoint that we implemented just a moment ago. Something a little new with this endpoint is that if we take a look in the task list service here, we have our first instance of us explicitly throwing an exception, in this case, an illegal argument exception. So next up, let's add some proper error handling for our endpoints. So we've implemented the create task list functionality and we're throwing exceptions there, but we're not doing anything to handle them. So let's improve on this by implementing proper error handling. So first, let's create a record to represent our error response. So within of domain and DTO here, I'm going to create a new Java class and I'm going to call this one error response. And that's going to be a Java record. Now within the Java record, I'm going to specify a few things. That I want the HTTP status code to be returned. That I want a string message to be returned. And then we'll have a string details to be returned. Whereas message is going to identify the type of error, details are going to give you the specifics. And of course, because we've used the Java record here, we automatically get construction, built-in getters, equals hashcode toString, and it's immutable by default. Next, let's create a global exception handler that will catch exceptions from our controllers and convert them into the appropriate HTTP responses. So let's create a new class in controllers, Java class, and we'll call this one global exception handler. And this will be a Java class. And let's expand this. So for this pattern, we're going to put the @controller advice on the top of this class. And that tells Spring that this class handles exceptions across all of our controllers. And next, we're going to add a method to handle those exceptions. So it'll be a public method, and it will return a response entity of type error response, which we've just created in our DTOs package. And we'll call this one handle exceptions. And that's going to take two arguments. The first one is a runtime exception. And the second one is a web request, which we'll call request. Now let's implement this method. So first, let's create a new error response. Now for the exceptions that we're throwing, the illegal argument exceptions, we're going to want to return the HTTP status of 400 or bad request, because the caller has sent a request which is invalid. So we can do that by first specifying the HTTP status code of HTTP status dot bad request, and then we can call value on there, and that will give us HTTP status 400. So next we're going to give a string message, and we're going to get this from the exception. Now we need to be careful about exposing internal details through this exception message, but for this particular case, I believe it'll be okay. So we're going to say exception.getMessage, and that will be passed as the message there. And now for the details, we'll go web request dot get description. And as for include client info, let's just say false. That should hopefully be helpful to the caller. So all that's left to do now is to return the new response entity. And we'll say error response. And we're going to return this with HTTP status dot bad request. Now you'll notice in the method signature here, we simply have a runtime exception. We haven't specified to handle the illegal argument exception that we're throwing in our application. And we can do that with an annotation on the top of the method here. So we'll say at exception handler, and we'll specify that this handles an illegal argument exception dot class, because the illegal argument exception is the one that we're throwing in our application. Of course, you can go ahead and use a custom exception, but we're just going to use illegal argument exception in this case. So typically how this would work is the illegal argument exception would propagate up to Spring's exception handling mechanism. Spring finds our controller advised class and then matches the exception type against our handler method. In this case, the illegal argument exception. Our handler method is then going to create an error response with the HTTP status of 400 or bad request, the exception message, and then some request details. Spring is then going to convert the error response to JSON and then send that to the client. We've used a response entity here to allow us to specify the HTTP status code of that response. So with that handled then, let's implement our get task list endpoint. Now that we can list and create task lists, let's implement the ability to retrieve a single task list by its ID. This functionality is essential for viewing and editing individual task lists, and we'll need to add methods to both our service and controller layers. So first, let's open up services here and then go to our task list service. And we're going to add a new method. And this one is going to return an optional of task list. Let's import optional. And we'll call this method get task list. And it will take a single argument, a UUID, which we'll call ID. So we're going to pass in the ID of the task list, and if it exists in the database, it will be returned, and if it doesn't exist, we'll get an optional.empty. So let's now go down to our task list service implementation, and let's expand that. So we have that red squiggle once more because we have a new method that we haven't implemented. So let's implement that method. And we have an optional.empty returned, so let's remove that. And let's implement this properly. As it turns out, the implementation for this method is fairly straightforward. We're simply going to call the task list repository that we already have access to up here. And we're going to call the method find by ID, passing in the ID that's passed in to this method. And this will do all of the work for us. It will look up the task list via its ID, returning it if it exists, and returning an optional.empty if it doesn't. So now let's head over to our controller and implement our endpoint. Let's expand that. So let's create a new method here, and we'll say it's public. Return an optional of task list DTO. Note it's DTO and not task list entity. Let's import optional. And we'll call this one get task list. Now let's add an annotation to the top here. This is going to use the HTTP get verb. So we're going to select the get mapping annotation. Within the arguments to this annotation, we're going to specify the path of this particular endpoint. So we happen to know from earlier, the path is going to be /task lists and then the ID of the task list. So within here, we're going to say /, and then in curly braces, we're going to say task list ID. And because we've used this notation, inside of the arguments to our method here, we can say at path variable, specifying the name of the path variable, which is task list ID. We'll then assign that to a UUID, and we'll call it task list ID, and then we'll import UUID. There we go. So this will allow us to access the UUID, so the task list ID that's been passed in the URL path. And the implementation for this endpoint is to return task list service, call the method that we just implemented, in this case, get task list, passing in the task list ID from our URL, and then we'll have an optional of task list. So let's convert that to an optional of task list DTO. And we can do that by calling .map, and then we'll call our task list mapper to DTO. And that is our endpoint method implemented. So with that, let's restart our backend application here. That looks to have restarted fine. So let's now head over to our front end. So here we are back on our front end. Now let's see our endpoint working. So let's click on a new task list here. And if we just expand our networks panel, we can see that we have our calls to list task lists, and we have our call here, which is currently receiving a HTTP 404, but this is for list tasks. So how do we try out our new endpoint? Well, it's rather simple. Let's clear this networks panel and let's just refresh our page. If we just pull that up a little bit further, let's take a look at these calls. And here we have our call to our get tasks endpoint. We can see here that we've got a HTTP 200. And if we take a look at the response here, we can see that we've got our task returned, ID, title, description, count, so on and so forth. Of course, the get task endpoint is required because when we refresh our page, the state refreshes and we just need to fetch that particular task because that is all we are displaying right here. So in summary then, we added a new method to the task list service interface there, and then we implemented it on task list service import. And all it really does is use the task list repository to find by ID with the ID provided. We then updated our controller, adding a new endpoint, this one a get mapping, providing the task list ID in the URL there, accessing it here, and then passing it into task list service.getTaskLists. Of course, that will return a task list. So we use the task list mapper to convert that to a task list DTO to return that to the caller. So now that we're able to retrieve individual task lists, let's now move on to the update task list endpoint. Now that we can create and retrieve task lists, let's implement the ability to update existing task lists. This will allow users to modify the title and description of their task list. We'll need to add methods to both our service and controller layers for this. So first, let's head over to our services here and open up task list service. Let's expand that. Now we're going to add a new method declaration in this task list service interface, and it's going to return a task list. And we'll call this one update task list. And as an argument, it will take the UUID of the task list that it is to update, so task list ID. And it will also take a representation of the task list of type task list, and let's just call this task list. So we specify the ID of the task list we'd like to update, and then we pass in a representation of what we like to update it to. That then saves in the database, and we return the saved representation of our task list. This is often referred to as a full update because anything that we provide in this task list here will just overwrite whatever's in the database. So now that we've added our new method to task list service, let's go to the implementation, hover over here, and then go implement methods. Click OK. So let's remove this. Now for the first thing, let's make sure that the task list passed in does in fact have an ID. Although it strictly doesn't need an ID, by convention, we want it to. So we'll say if null equals task list.getID. Then we're going to throw an illegal argument exception. And we'll say task list must have an ID. So now I'm going to check that task list ID matches the task list ID passed in here. Because if it doesn't, it might mean the caller's trying to do something they're not supposed to. So let's do that check now. We'll say if, and then we'll say objects dot equals, and then we'll say task list dot get ID. And as our second argument, we'll say task list ID. But we're not checking if they're equal, we're checking that they're not equal. So let's put an exclamation mark before that check. So if the IDs don't match, what do we want to do? Well, let's throw a new illegal argument exception. And we'll say, attempting to change task list ID. This is not permitted. And let's fix that typo. Semicolon. Okay, we've done some validation. So let's move on to actually updating the task list that we have in the database. So first we're going to need to get that task list. So let's say task list repository dot find by ID, and then we'll search for task list ID. So this will return an optional of task list. So what do we want to happen when the task list isn't found? Well, let's say or else throw. And in here, we'll say new illegal argument exception. And let's say task list not found. And let's place that on a new line. And let's assign this to a variable of task list. And let's say existing task list. So now that we have this task list from the database, let's go about doing that full update on it. So we'll say existing task list dot set title, and we'll use task list dot get title for that. We'll say existing task list dot set description, task list dot get description, existing task list dot set updated, and we'll do that to local datetime dot now. And now we will call task list repository once more, dot save the existing task list. And in doing so, save the changes that we've made to it, and we will return that because the save method there returns a task list. So this will allow us to update the title and the description of the task list, and it also updates the updated date time, which is good for audit purposes. So with that done then, let's move on to our controller. So we'll need to add a new endpoint for this one, and we're going to use the HTTP put verb. So we'll say put mapping, and the path for this one will be task list ID. So we're specifying the ID in the URL for the task list that we're looking to update. So let's say public. This one's going to return a task list DTO, and we'll call this method update task list. Of course, we want to use that path variable annotation in here to access this value here, which will assign to the variable of UUID task list ID. And then we're also going to want the request body because we're going to be sending a representation of the task list that we're looking to update in the body. So we'll say request body, and this one's going to be a task list DTO. And we'll call this one task list DTO. So let's call our service, task list service dot, and we'll call update task list that we've just implemented. We'll pass in the task list ID, which comes from our path. So this here. And now we need to pass in a task list. So we're going to use our task list mapper dot from DTO, passing in the task list DTO. This, of course, is going to give us a task list, which we'll assign to the variable of updated task list. Now, all that's left to do is to return a task list DTO, which we can do by saying task list mapper dot to DTO, passing in the updated task list. So with our method implemented now, let's try it out. So let's restart our backend. So it looks like our backend has restarted successfully. So let's head over to our front end. So here we are back in our front end. So let's try and update our task list. So let's click on a new task list here. And we can update a task list with this button on the top right. So this gives us a form which is populated with the information that we set previously, a new task list, and this is a description. So we're going to say this is a newer task list, and we'll say this is a better description. And before we click on update, let's just clear our networks panel there. And let's click on update task list and try out our new endpoint. Great, okay, so let's take a look at this. So we can see our put request to this URL here, task list, specifying the ID of the task list, has received a HTTP 200, which is great. Now let's take a look at the payload that we've sent. So we can see here the representation of our task list. So the ID, the title, the description. Bear in mind, these are the values that we put into our edit form, a newer task list, a better description. If we take a look at the response, we can see that we have an updated title, a newer task list, and an updated description, a better description. What's more, we're redirected back to the list task list page, and we can see the new title on this task list. If we give that a click, we can see a newer task list. So it seems like our update endpoint is working as expected. So in summary then, we've added a new method to our task list service, this one called update task list, which takes the ID of the task list to update and a representation of what we want that updated task list to look like. It then saves that in the database and returns the updated task list. We've of course implemented it by doing some light validation to begin with, and then retrieving the existing task list from the database, throwing an illegal argument exception if it doesn't exist, which of course will be handled by our global exception handler, returning a HTTP 400. We then went about updating that existing task list by setting the title and the description, and also setting the updated date time. We then save the updated task list to the database and returning it as well. And then we look to use this particular method over in our controller, to which we've added a new endpoint, a put mapping this time, specifying the task list ID in the URL path. We then expect to see that representation of our updated task list as the request body. We then go about doing the conversions between DTO and entity, of course, calling our update task list. With all of this information, returning the updated task list as a task list DTO to the caller. So with our update task list endpoint implemented, let's move on to the delete task list endpoint. Now that we can create, retrieve, and update task lists, let's implement the ability to delete them. This will allow users to remove task lists they no longer need. Due to our cascade configuration, deleting a task list will also delete all tasks associated with it. So let's start over on our task list service. Let's expand that. And to our task list service, we're going to add another method. This one isn't going to return anything, so it's going to be a void method. And we'll call this one delete task list, passing in the UUID task list ID. So the ID of the task list that we're looking to delete. So with that done, let's look to implement that. Let's hover over this red squiggle and click on implement methods. And then we'll click on OK. And we can see we have our delete task list method stub. So the implementation for this particular method is rather straightforward. We're going to use the task list repository, and we're going to call the method on that task list repository of delete by ID. And then we'll simply pass in the task list ID, and that will delete the task list from the database. Note that we don't check if the task list exists before deleting it. Spring Data JPA's delete by ID method handles non-existing entities gracefully. So let's go about updating our controller now. And let's expand that. So we're going to add a new method to our controller, and this one's going to use the HTTP delete verb. So we'll say delete mapping. And the path for this one is going to be / and then we'll say task list ID. So this is going to be the URL format where we specify the ID of the task list to delete in the URL. So we'll say public void, because this method, this endpoint, isn't going to return anything in the body. It's just going to return the HTTP status code. So let's call this one delete task list. And we'll access that task list ID in the URL with @path variable, specifying task list ID. I will assign this to the variable of UUID type task list ID. And for the method implementation, we're simply going to say task list service, and then we'll call the method that we just added, delete task list, passing in the ID from the URL. And with that, we've implemented our delete task list endpoint. So let's restart our backend and then try it out in our front end. There we go. That's the backend restarted. Let's head back to the front end now. So here we are back in our front end. Let's try deleting a task list. So we'll click on this newer task list here. And if we scroll down a little bit, we have this delete task list button. So let's just expand our networks panel and clear that. Now, let's see what happens when we click on delete task list. So we can see the request has been sent. We've got a HTTP 200 response. Let's just take a look at that. So we can see the URL specifying the ID of the task list to delete, the HTTP verb delete, and a HTTP 200 OK response. That's what we're expecting. And further to that, we can see that our list of task lists is now empty. So it looks like our delete task list endpoint is working as expected. So in summary then, we've added a new method to our task list service called delete task list. This doesn't return anything, it's a void method, and it takes a UUID as an argument called task list ID, and this is the ID of the task list to delete. We then implemented that over in our task list service import class, and we can see here we're simply just calling the task list repository, delete by ID, passing in that task list ID. This will delete the task list from the database and even handles the case when it doesn't exist in the first place. That's handled gracefully. With that method implemented on our service, we've then used that in our controller. We created a new endpoint, delete task list, which is called with the delete HTTP verb, specifying the ID of the task list to delete in the URL path. We then get that task list ID and simply pass it to the method that we just implemented on our service, delete task list, and that will delete the task list from the database. This method doesn't return anything other than the HTTP status code, which we've seen to be 200, a success. So that wraps up the create, read, update, and delete behavior for our task list. Let's now move on to our tasks, starting with the list tasks endpoint. Now that we have our task list CRUD operations implemented, let's start working on task management by implementing the ability to list tasks within a specific task list. We'll need to add methods to both our service and controller layers to handle this functionality. So first, let's create a new service inside of the services package here, and we're going to call this one task service. Only it's not going to be a class yet, but an interface. And let's expand that. So for the moment, there's only going to be a single method on the task service interface. It's going to return a list of tasks. Let's import list. And we'll call this method list tasks. And it will take a single argument, which is a UUID, and it will be the task list ID. So essentially then we'll pass the ID of the task list, and then we'll get the list of tasks that belong to that task list. So that's our interface for the moment. Let's now create an implementation for this interface. So within the import directory here, we'll go new Java class, and we'll call this one task service import, and this will be a class. Let's expand that, and we'll say implements task service, and we can see we get a red squiggle. If we implement methods, click OK, we can see that we have a method stub for our list tasks method. Now, before we continue, let's put the @service annotation on the top of this class. So let's look to implement our list tasks method. So we need to interact with the database. So we need our repository. So let's define here a private final instance variable of type task repository. And we'll call this one task repository. We get a red squiggle there. So if we hover over it, let's add a constructor parameter. And now we have access to our task repository within of the task service. So if we remove the list of, let's now call our task repository dot, and we'll say find by task list ID. You may remember this from earlier. This was one of our custom queries that we created in our task repository. So let's pass in the task list ID. And there we go. We've implemented our task lists because find by task list ID will return a list of tasks which match that task list ID. So all of the tasks that belong to that task list. So let's now create a controller to deal with tasks. So let's go up here, and in our controllers package, let's create a new class, and we'll call this one tasks controller. And that will be a Java class. And let's expand that. So let's put the @REST controller annotation on the top of this class because this does represent a REST controller. And now we're going to specify the request mapping. So we'll say request mapping. And for the path, we're going to say /task lists. /task list ID /tasks. So every single method on this controller will have this as a path prefix, meaning that we always specify the task list ID in the URL when we deal with our tasks. When we create, read, update, and delete our tasks, we always specify the task list ID that they belong to in the URL. So we know from implementing our task list controller that we're going to need both our service and our mapper. So let's say private final task service, which we'll call task service, and then private final task mapper, and we'll call that one task mapper. Now, if we hover over these, add constructor parameters, selecting both, and then OK. And there's our controller, which will inject these so we have access to them in our endpoint methods. So for the list tasks endpoint, that's going to be a get mapping using the HTTP verb get. And we don't need to specify a path here because it's going to use the one defined on the controller, nothing additional. So our method is going to be public and return a list of task DTO. Let's import list, and we'll call this method list tasks. Now we want to get that task list ID from the URL. So we'll say at path variable, specifying task list ID. And we'll assign that to the variable of task list ID, which will be a UUID type. So now to implement our method, let's return our call to the task service dot list tasks, passing in the task list ID there. But of course, that's going to return for us a list of tasks, and we need a list of task DTOs. So let's do stream. In fact, let's put that on a new line. Stream.map, and then we'll call our task mapper to DTO methods, and then we'll turn that back into a list with toList. And that will return for us our list of tasks that belong to that task list. So let's restart our backend and then try out our new endpoint in our front end. Great, so the backend seems to have started up successfully. Let's now head over to our front end. So here we are back in our front end. Now, in order to see a list of tasks, we're going to need a task list. So let's create a new one. And we'll say new task list. This will have tasks as the description. And let's create this. Great, so we now have a new task list. Let's go into that. And we can see, if we expand up here, we're no longer getting 404s. If we take a look at this call here, we can see it calls the endpoint that we have just implemented, HTTP GET to task lists, the ID of the task list /tasks. We have a HTTP 200, so let's take a look at the response. Great, we just have an empty array. Of course, we haven't created any tasks in our system yet. So, in summary then, we created a brand new interface here called task service. It has only a single method on it at the moment, list tasks, which takes the ID of the task list and then returns all tasks associated with that task list. We then implemented that over in task service import here, with the implementation being a call to our custom query on our task repository. Then we created a brand new controller called task controller, where we call our task service and our task mapper inside of our new endpoint list tasks. We simply call our service, getting a list of tasks, then use the task mapper to turn them into DTOs, returning them to the caller. So now that we can get a list of tasks, let's move on to the create task endpoint so we can start creating some tasks. Now that we can list tasks, let's implement the ability to create new ones within a task list. We'll need to add methods to both our service and controller layers to handle this functionality. So first, let's add the create method on our task service interface. Let's expand that. So create task is going to return a task that it created. Of course, we'll call that method create task. And it's going to require the UUID of the task list, which we'll call task list ID. And then it will need the task to create. We need to specify the task list ID because we need to know which task list to assign this task to. So with our new method declared, let's now go down to our task service import. Let's hover over this and implement our new method. So let's delete that. So now for some validation. And the first thing that I'm going to do is make sure that the ID on our task object here is null. Because of course this method is for creating brand new tasks, not for updating existing ones. So we'll say if null does not equal task.getID. We're going to throw a new illegal argument exception, and we'll say in there task already has an ID. Great, so we can be certain that this task has a null ID. So it should represent a brand new task. Now let's make sure that our task actually has a title, because that's required in our database. So let's say if null equals task.getTitle, or task.getTitle dot is blank, because we don't want an empty string either. We're going to throw a new illegal argument exception, and we'll say task must have a title. Now, if we take a look at our task once more, we always want an ID, but we're going to generate one of those. We always want a title, and we've just made sure through a validation check. Description is optional, so we don't mind too much there. The same with due date, that's optional. Now, status, we always want a status, and the same for priority. So let's make sure that's the case in our create method. So first, let's deal with the priority. So let's say task.getPriority. And this could potentially be null. So we'll say optional of nullable task.getPriority. And in the case that it is null, we're going to default to task priority dot medium. And let's assign that to a variable called task priority. And let's place that on a new line. So that's priority. Let's now do status. Well, here's the thing about status. We're actually creating a brand new task. We can't create a task that's closed. So we're going to default status to open. So we'll say task status equals task status dot open. Great. So now let's start thinking about our task list. So we're going to need to get our task list from the database. However, we don't have a way of doing that currently. So let's scroll up to the top of our class here. And in addition to the task repository, I'm going to add private final task list repository, and we'll add that to the constructor as well. So we can now use this task list repository to retrieve the task list from the database. So we'll say task list repository dot find by ID, passing in the task list ID. Now we always want the task list to exist. Now this is going to return an optional, so there will be the chance that this task list doesn't exist in the database. So let's deal with that. Let's say or else throw a new illegal argument exception, and we'll say here invalid task list ID provided. And let's assign that to a variable task list. Great, so we've now got our task list from the database. So let's go about actually saving our task against this task list. So let's create our task. So we'll say task to save equals new task. And now we can start populating the all arguments constructor. So for the ID, we're going to specify null and have JPA generate that for us. For the title, we'll say task.getTitle. For the description, task.getDescription. For the due date, task.getDueDate. For the priority, we'll use the task priority up above. And for the status, we'll use the task status up above, which will be open. And now we'll save the task priority. So we'll say task priority. So next on the list is the task list. So we're going to provide the task list above. And now we can specify the created and the updated local date times. So these are both going to be the same to begin with. So let's create a variable, local date time. We'll call that now. And we'll assign that the value of local date time dot now. And we'll provide that to the remaining two. There we go. So now we have our task to save. So all that's left for us to do then is to call our task repository, .save, passing in our task to save, and then we will return that to the caller. So with the first iteration of our create task method implemented, let's now look to use this in our controller. So let's head over to our task controller here. And let's create a new endpoint. And this one's going to use the post mapping. Again, it's just going to use the URL path that's been specified up here. So we don't need to add anything additional in the post mapping annotation. So let's specify a public method that returns a task DTO. So the task that was created, and we'll call this one create task. Now, much like our list tasks method here, we're going to need to get a hold of the task list ID in the URL. So I'm just going to copy that from up there and place that in there. However, for create tasks, we're also going to need to get hold of the request body, which we're going to do with the @request_body annotation. And we're expecting a task DTO in the body, which we'll call task DTO. So we'll now call our task service and the create task method that we just implemented, passing in the task list ID, and then we want to pass in a task. So let's say task mapper dot from DTO, passing in the task DTO from the request body. Let's just place these on some new lines. And let's assign that to a variable called task created task. And let's just import that. So now all that's left for us to do is to return a task DTO, which we can do by calling our task mapper dot to DTO on our created task. And that's our create task method implemented. So let's try it out in our front end, first by restarting our backend. There we go. So the backend looks to have started up successfully. So let's head back over to our front end now. So here we are back in our front end. Let's look to create a task on this task list. And we can do so by clicking on the task list here and then clicking on add task. Let's just pull the networks panel down a little bit. So let's give this task a name. We'll say a new task. A description. This is a brand new task. Now the due date is optional, but for the sake of argument, let's set it to the 1st of December, 2030. Give ourselves plenty of time for this. For priority, let's say this is a high priority task. And before we click on create task, let's just clear the networks panel and click on create task. If we scroll up here, there it is. So this is our call to our create tasks endpoint. We can see the HTTP post here and a HTTP 200 returned in the response. If you take a look at the payload, we can see the task that we're looking to create, a new task, brand new task, due date, priority. And if we look at the response, we can see that same task, but it has an ID, title, description, due date, priority, and status. So if we were to pull down the networks panel now and scroll down, we can see that our list tasks endpoint is also working because we have our new task listed here on the screen. So in summary then, we added a new method to our task service called create task, which takes the ID of the task list to create the task within and the task to create. It then returns the task that's been created. We implemented that over in our task service import, doing some validation, making sure that we have all of the variables that we need to create our task. We get the task list from the database, and then we use that to create our task in the database against that task list. Then in our task controller, we added a new endpoint, this one using the HTTP post verb, and then we get the task list ID from the URL, get the task DTO from the request body, and then pass that information into the create method that we created on our service using our task mapper to do the conversion from DTO and to DTO. So now that we're able to create and list our tasks, let's now implement our get task endpoint. Now that we can list and create tasks, let's implement the ability to retrieve a single task by its ID. This functionality is essential for viewing and editing individual tasks. We'll need to add methods to both our service and controller layers for this. So first, let's head over to the task service here. Let's expand that. And let's add a new method to this. It will return an optional of task. Let's import optional. And we'll call this one getTask. And we'll pass into this a UUID, which is the task list ID. And we'll pass in a second UUID, which will be the task ID. We're returning an optional task here because the requested task might not exist. So with this new method added, let's now look to implement it. Hover over here to implement those methods, click on OK. And we have this method stub currently returning an optional empty. To implement this method, it's fairly straightforward. We'll say task repository dot, and we'll call find by task list and ID, which is the second custom query that we implemented on our repository. We'll pass in the task list ID and we'll pass in the task ID. And like that, we've implemented our getTask method. So let's move over to our controller and implement that endpoint. So the getTask endpoint is going to use the get mapping. And in addition to the URL path that we specified up here, we're also going to ask for the task ID in the URL, which we'll do by specifying the path as /task ID. Then we'll specify a public endpoint returning an optional of task DTO. Let's import optional. And we'll call this one getTask. Now getTask is going to take two arguments. The first one is going to be the task list ID, just the same as create task and list task. And the second one is going to be the task ID. So I'm going to paste it again and just change the path variable from task list ID to task ID. And then we'll change task list ID over here to be task ID. So this will give us access to both the task list ID passed in the URL and the task ID passed in the URL. So now to implement the method, let's call our task service and call the method that we just implemented, getTask, passing in the task list ID and the task ID. Now this may return a task and it may return an optional empty. So let's deal with the case where it does return a task, calling task mapper to DTO to convert it into a DTO. And as we're returning an optional task DTO, so Spring knows what to do with that optional, we can simply just return this. So with our new endpoint implemented then, let's restart our backend and try out our new endpoint in our front end. Okay, so the backend seems to have started fine. Let's move over to the front end now. So here we are in our front end. Let's try out our getTask endpoint. Now to try it out, we're going to click on the new task list that we've created here, and then we're going to click on the update task button. And that's going to display the update task screen, which we can then use to try out our new getTask endpoint. Now currently we haven't implemented any update functionality. The reason we're using the update task screen is because it displays a single task and therefore calls the getTask endpoint. So if we were to clear our networks panel and then click on the update task button, we can see that we have the update task screen here and we have some task information. A new task, this is a brand new task, due date, high priority. Now if we take a look at our networks panel, we can see a call made to our getTask endpoint here. There's the task list ID, there's our task ID, HTTP GET, HTTP 200 response. Now, if we take a look at that response, we can see the task. So it looks like our getTask endpoint is working as expected. So in summary then, we added a new method to our task service called getTask. It accepts a task list ID and a task ID and then returns an optional of task. We implemented that over in our task service import, simply calling through to the custom query that we've already created on our repository, find by task list ID and ID. And then with that service method implemented, we updated our controller, adding a new get mapping endpoint here, which has both the task list and the task ID specified in the URL, which it then passes on to our task service.getTask, returning the optional task DTO. which of course we get a task DTO from our task by using the task mapper here. So that's our get task endpoint implemented. Let's now move on to that update task endpoint. Now that we can create and retrieve tasks, let's implement the ability to update existing tasks. This will allow users to modify task details and mark tasks as complete. We'll need to add methods to both our service and controller layers for this. So first, let's update the methods in our task service interface. So let's go to services and open up task service. Let's expand that. So the method we're to add is going to return a task, and we'll call that one update task. And it will take a UUID as its first argument, and that will represent the task list ID, and it will take another UUID as a second argument, and this will be the task ID, so the ID of the task. And its third argument is going to be a task, and that's going to be the representation of the task, including all of its updates. So we'll provide the ID of both the task list and the task, plus the representation of the task that we want it updated to. That will then be saved in the database, and we'll have a task object returned, and that will be the updated task. So with that added, let's now move over to the implementation. Hover over this, we'll go to implement methods, and we'll select OK. And now we have a method stub for our update task method. So let's delete this. So just like we did on our task list, we should start by doing a light bit of validation. So we'll check first to make sure that the task provided has an ID. This is the opposite to what we were doing in the create method, remember? In the create method, we don't want a task to have an ID because that's a new task to be created. But in the update method, we want that task to have an ID because we are updating an existing task. So we're going to say if null equals task.getID, then we'll throw a new illegal argument exception with the message of task must have an ID. Now let's make sure that the ID on the task object matches the task ID passed in here. If they're different, it might be a user trying to update the ID of their task, which of course we don't want them to be able to do. So let's put a if statement here, and we'll say if objects.equals, with the first argument being our task ID, and the second argument being task.getID. But of course, we're checking that they're not equal. So let's put an exclamation mark at the beginning there. We will throw a new illegal argument exception, and we'll simply say task IDs do not match. As this is a full update, we want to make sure that our task is a proper representation of a task with all of its information, including its priority and status, which could be null. So let's now do a check to see that they're not null. So we'll say if null equals task.getPriority, then we're going to throw a new illegal argument exception, and we'll say task must have a valid priority. And we'll do the same for status now, and we'll say if null equals task.getStatus, then we're going to throw a new illegal argument exception, and we'll say task must have a valid status. Of course, we can build on this validation in future, but that should be enough for the moment. So let's now look to get our task from the database. So we'll say task repository dot find by task list ID and ID, passing in the task list ID and the task ID. And this will return an optional. So let's deal with the case where the task doesn't exist in the database. And we'll say or else throw. In fact, let's put that on a new line. A new illegal argument exception. And we'll say task not found. This may be a good opportunity for a custom exception, but we'll just use an illegal argument exception for the moment. We'll assign this to a variable called existing task. So now that we have our existing task, let's go about updating it using the information from our task argument here. So we'll say existing task dot set title from task.getTitle, existing task dot set description from task.getDescription, we'll set the due date from task.getDueDate. And now the priority from task.getPriority. And now the status from task.getStatus. And finally, we'll update the existing task's updated local date time. Set updated to be local date time.now. So the time and date right now. And now we'll use our task repository to save the task in the database with all of its updates and return that to the caller. So after a bit of light validation, we get that task from the database, and then we go about updating it using the information from our task object here, and then we save it in the database and return it to the caller. So with our method implemented then, let's now move on to our controller. Let's expand that, scroll down, and let's add a new endpoint now. So this one is going to be a put mapping because we're using the HTTP verb put. And the path for this one is also going to specify the task ID. We'll say a public method returning a task DTO, which is the updated task. And we'll call this one update task. Now we're going to need to extract the task list ID and the task ID from the URL. So we'll do the same as we've done up here. So let's paste those path variables for task list ID and task ID. And we're also going to want a request body. So we'll say at request body. And it's going to be a task DTO. And we'll call that one task DTO. And that's going to be the representation of the task that we've updated in our front end. So let's call our task service .update task, and we'll pass in the task list ID, the task ID, and we'll pass in the representation of the task, which we'll have to map. So let's call task mapper dot from DTO task DTO. Let's put these on new lines. There we go, and let's assign this to a variable called updated task. Now we just need to return the updated task as a task DTO. So we'll use our task mapper dot to DTO on the updated task. And that is our implemented endpoint method. So with that done then, let's restart our backend and try out our new endpoint in our front end. So that's the backend restarted successfully. Let's now go over to our front end. So here we are back in our front end. Let's try updating a task. So let's click on new task list here. And this is our task. So let's try updating it. So this is the information from our task as it is now. A new task, a brand new task, due date, priority, and then we can update that. So let's try a newer task. This is a much newer new task. The due date, I don't know, about 2030. Maybe let's make that 2035. This is still a high priority, or is it? Maybe it's a low priority. And then we're going to click on update task. But before we do, let's refresh. And now let's click on update task. Okay, let's take a look at the request here. So we can see the HTTP put made to this URL here, specifying the task list ID and the task ID. We take a look at the payload. We can see the description that we gave our task. This is a much newer task. The due date, 2035. And we can see that this payload does have an ID, so the task exists, it does have an ID. It's now a low priority. It's still an open task. And we can see here, the new title, a newer task. So if we take a look now in our UI, we can see that this now has a new title, a newer task. It's a low priority, and we have until 2035 to do this task. Now, I also mentioned that this will allow us to complete a task. So if we clear our networks panel here, scroll down, and if we try clicking this little tick box next to the task, we can see another request has been sent. We can see here, it's pretty much the same, except for the status is now closed. And we can see put 200 to the same URL, so it looks like it's been accepted successfully. We can also see the progress bar is filled up at the top here, and it looks like our task list is complete. So now that we're able to update our tasks, let's move on to the final operation, which is being able to delete our tasks. Now that we can create, retrieve, and update tasks, let's implement the ability to delete them. However, rather than just a simple delete like we used in task lists, let's make use of transactions, as it's a great topic to move on to once you've completed this project. So first, let's open up our task service here, and we're going to add a new method. This one's going to be a void method, and we'll call it delete task. The first argument will be a UUID, which we'll call task list ID, and the second one will be a UUID, which we'll call task ID. So with that done then, let's go over to our implementation. Let's hover over this, and then go implement methods. Click OK. And we now have a method stub for delete task. So one option for implementing this method could be to call the task repository dot delete by ID and then pass in the task ID. This will delete the task as identified by this task ID. However, we're not using this task list ID anywhere. So what that means is we're not checking to make sure that this task exists on this task list before deleting it. And although we're unlikely to get this sort of request from the front end, because of course it's only ever going to provide the task list ID corresponding to the task, although if this was to be exposed as a public REST API, we would certainly want to make sure that the task belongs to the correct task list before we delete it. So let's add a new method on our task repository, which allows us to delete a task by specifying both the task list and the task ID. So let's go to task repository here. And let's just expand this. And to our task repository, we're going to add a void method here. And we're going to call this one delete by task list ID and ID. And similar to the method declaration above it, we're going to pass in the UUID, which is the task list ID, and a second UUID, which is simply going to be the ID. So this being the ID of the task, and of course this being the ID of the task list. Because it is a JPA repository, we don't have to provide the implementation for this method. Spring Data JPA is going to do it for us. So now that we have this new method in our task repository, let's go back to our task service import. And then rather than call delete by ID, let's call delete by task list ID and ID. And we'll provide the task list ID and the task ID in there. Now you might remember from earlier I mentioned the word transactions, and I can tell you now that we will need to use transactions for this, but we won't do so right now. Let's see why we need to use transactions for this. So with our service implemented, let's move on to our controller. And we're going to add a delete mapping. This is going to specify the task ID. And this is going to be public. It's not going to return anything, so we say void, and we'll call this one delete task. And because we're going to need both the task list ID and the task ID, I'm just going to copy these from up here and place them in here. And now we can get to implementing our method. So for this one, we simply need to call our service, task service dot delete task, passing in both the task list ID and the task ID. So let's restart our backend and open up our front end, and let's see if this works or not. Okay, so that's the backend restarted. Let's move over to the front end. So here we are back in our front end. So let's go to new task list, and let's scroll down to our task here. Let's just clear out our networks panel, and let's now attempt to delete this task. And we can see here, we get a HTTP 500, an internal server error. So let's head back to our backend and see why this is. So here we are back in our backend, and we can see here we have a rather large stack trace. So looking at this, we can see we've got an exception here called transaction required exception. No entity manager with the actual transaction available for the current thread. So we cannot reliably process a remove call. Now you might be wondering why we didn't need this for our delete by ID. So if we were to go back to our task list service, go to the implementation of delete task list, we can see that we are successfully using delete by ID here. But if we were to take a look at this, go to the implementation, we can see that it has this transactional annotation on the top. But because we're using a custom delete method now, we need to add the @transactional annotation to the top of that one. Now, typically, we would add the @transactional annotation in the service. So if we go back to our task service here, go to the delete task implementation, and then to the top of this method, the delete task method, we're going to add the @transactional annotation. Now, if we restart our backend, that's the backend restarted successfully. So let's go back to the front end. And here we are back in our front end. So if we were to attempt to delete the task once more, we can see that this time we get HTTP 200 and the task was deleted successfully. Now this @transactional annotation is important because it ensures the delete operation happens within a database transaction. So if any part of that delete operation fails, then the entire operation is rolled back. And that's there to maintain database consistency, even if errors occurred during the deletion. And it's important to use this @transactional annotation when we delete data or attempt to make any changes, such as updating. So you might remember from earlier, but if we take a look inside of our task list service, go to the update task list implementation here, let's expand that. And if we scroll down a little bit, we can see that we're actually making multiple calls to our task list repository, find by ID, save. And this has been working so far, but there is a risk. If the task list were to change in the database between this call, find by ID, and this call, save, we could potentially end up with some missing data in the database. We could have an inconsistent state. So although there hasn't been any exceptions, it also pays to put the @transactional annotation on top of any service calls which make multiple calls to a repository. So update task list is a prime example. We scroll up here. Single call for list task lists, so we won't worry about that one. Create task list is only making a single call to the database here, save. Get task list, again, find by ID, a single call to the repository. Update task list, we've added the @transactional annotation to the top of. And then delete task list, we're using delete by ID, which already has the @transactional annotation on the top of it. So that's our task list service. Let's now take a look at our task service. Go to the implementation, let's expand this. So list tasks, single call. Create task. In this case, we have multiple calls because we are attempting to get the task list from the database, and then we're attempting to save the task. So to the top of create task here, we're going to add the @transactional annotation. If we scroll down, get task, single call to the repository, so a single database call, and update task here, one call, two calls. So we'll make sure that update task also has the @transactional annotation on the top there. And of course, we already have one on delete task. And with that, we made sure that all of the relevant business logic now happens inside of a database transaction. So to round everything off, let's restart our backend and then take a look at our front end. Great, so that is the backend restarted. Let's head over to the front end one last time. So let's just make sure that all of our functionality works before signing off this project. So we're going to create a new task list here, and we're going to say our final task list, the last one. And we'll click on create task list. And we have one created. Perfect. Let's attempt to update this. And we'll call this one our final task list, maybe. And click on update task list. Great, so that seems to have updated fine. Looking good. Now let's just try deleting a task list. So let's do the old one here. Scroll down and delete that task list. Looking good, HTTP 200. So let's go into our new task list. And let's try adding a new task here. We'll say our final task, the very last one. And we'll say this is due by the December 1st, 2032. It's a high priority, and let's attempt to create this task. Great, so that seems to have been created fine. Let's see if we can update it. Let's complete the task. 200 there. Click on update. Perhaps. And then we'll click on update task here. Great, so the task seems to be updating fine as well. Can we look to delete that task? Yes, we can. That seems to work. And if we delete the task list, everything seems to be working as expected. So in one last summary then, we've added the delete task method to our task service here, which takes a task list ID and a task ID. In the implementation here, we call our task repository with a custom method here, which deletes by task list ID and ID. And because it's a custom delete method, we also add the @transactional annotation with our new delete task method implemented. We then use that in our controller on our new delete task endpoint here, which is a delete mapping specifying the task list ID and the task ID, which simply just calls task service.delete task. But with our first experience of transactions and why they're important, we also took this opportunity to update our task list service implementation here by adding the @transactional annotation to the update task list method. And then over in our task service implementation, we add the @transactional annotation to our create task method here, our update task method, and of course our delete task method, making sure that each of those methods operates inside of a single database transaction and is rolled back if there are any exceptions. I hope you found this project truly valuable, and there are more to come, so be sure to subscribe and hit that bell icon to be notified when they are released. Now, if you've had questions on why we've approached things the way that we have, then be sure to check out this video right here, which will almost certainly have the answers that you are looking for. I'll see you over there.